Hello, welcome to Aggregate e-learning series, an academic empowerment program developed by Aggregate Education Center, Abuja. Our subject this morning is mathematics, and our topic is solution of quadratic equation using completing the square method. In this class, we will learn the form of a perfect square, 2 steps for solving quadratic equations using completing the square method. 3. Use some examples to illustrate the completing the square method. 4. Use the completing the square method to derive the formula method, usually called the almighty formula those days. 5. Give you an assignment to test your understanding of the topic. Completing the square method uses the concept of perfect square. Here, an equation is said to be a perfect square if it is of the form x plus c all squared, where c is a constant. The objective here is to move the constant in a standard quadratic equation to the right hand side and turn the left hand side of the equation to a perfect square. What do we mean by this? Assuming we are given this quadratic equation, this side is the left hand side, and this side is the right hand side. Okay. So to move the constant plus 3 to the other side, what normally happens is we say x squared plus 2x plus 3. That is the equation on the left hand side. What do we do next? We will now ask ourselves, what do we do to plus 3 to reduce it to 0? So the way out here is to subtract 3 is equal to 0. Do we stop here? No, because we added something to an equation that we've been informed that it is balanced, that it is equal to something. That means if we're adding something on the left hand side of the way in balance, we equally need to add the same thing to the right hand side to make sure that it still remains balanced. Adding minus 3 to both sides, we have minus 3 is equal to 0 minus 3. Then plus 3 minus 3 will cancel out and become 0 as we expected, leaving us with x squared plus 2x is equal to 0 minus 3 is minus 3. Okay, so what we will now do in completing the square method is to work on this left hand side of the equation and make it to become a perfect square. Then the constant is already here, and by the time we work it out to be a perfect square, it will be of this form. Then we solve the equation. Okay. There are actually about 5 steps for solving quadratic equations using completing the square method. The first one is that whenever you are given a quadratic equation, you need to move the constant to the right hand side of the equation. Then 2, you need to ensure that the coefficient of the squared term, x squared, is 1. If it is not 1, then divide both sides of the equation with the coefficient of x squared to make it unity. So the question we need to ask ourselves here is, what is the coefficient of the squared term? The coefficient here is 2. So in this case, we need to divide through by 2 to make the coefficient of x 1. So the third step is to add the square of half coefficient of x to both sides. Then after doing that, then we take square root of both sides, remembering to put the plus or minus on the right hand side. Then you solve the equation. Okay, so let's walk through the step one by one. Now we have 2x squared plus 5x minus 3 is equal to 0. That's the given equation. Now, to move the constant to the right hand side of the equation, this is the right hand side. This is right hand side. Then this is left hand side. Okay. So the question we need to ask ourselves is, what do we do 2 minus 3 to reduce it to 0? But mind you, because of sign of equality, whatever we do here, we have to do here. So this gives us, since 3 is subtracted, we need to add 3 to balance it up. So minus 3 plus 3 is equal to 0 plus 3. Then minus 3 plus 3 we cancel out, leaving us with 2x squared plus 5x is equal to 0 plus 3 is 3. So that's the first step, to move the constant to the right hand side of the equation. Okay, then the next step is that we need to ensure that the coefficient of the squared term x squared is 1. Okay, we need to ask ourselves, is the coefficient 1? No, the coefficient is 2. Then if it is 2, divide both sides of the equation with the coefficient of x squared to make its coefficient unity. Okay, so in this case we'll have 2x squared divided by 2 plus 5x divided by 2 is equal to 3 divided by 2. So with this, we have this and this cancelling out. So basically leaving us with x squared plus 5 over 2 x is equal to 3 over 2. Okay, then the first step says add the square of half coefficient of x to both sides. So in this case, what is the square? We now say plus half dot, meaning multiplication. So this will be in bracket. What is the coefficient of x? 5 over 2. Squared. Then we do the same here, plus half coefficient of x squared. So this gives us x squared plus 5 over 2x plus, simplifying the brackets, 1 times 5 is 5, 2 times 2 is 4, squared is equal to 3 over 2 plus the same thing here, 5 over 4, all squared. So continuing with this, we already have x squared plus 5 over 2x plus 5 over 4 all squared is equal to 3 over 2 plus 5 over 4 all squared. So for us to turn this side into a perfect square, we simply need to do is to take x and take this sign and take this other number in brackets. So in this case it will be x plus 5 over 4 all squared. So that's what we need to do here. So that gives us, therefore we have x plus 5 over 4 all squared. Okay, so if you look back at this, you now notice that by the time you open back the perfect square, then you'll be able to get the left hand side of the equation. Okay, so that is the very easy way of picking what will be the perfect square. Pick the things in the brackets. Okay, then we'll now continue with this. Is equal to 3 over 2, then we open back what we have in the bracket here, 5 over 4 all squared will give us 5 squared is 25, 4 squared is 16. Then simplifying further, this gives us the LCM is 16. 16 divided by 2 is 8. 8 times 3 is 24 plus 25. Why 25? Because 16 divided by 16 is 1. 1 times 25 is 25. Then what does this give us? This gives us 5 plus 4, 9. Then 2 plus 2, 4, 49 over 16. This, therefore, we now have that x plus 5 over 4 all squared is equal to 49 over 16. Okay. Now we have x plus 5 over 4 all squared. To get rid of this square, we need to take square root of both sides. Why both sides? Because of this sign of equality. Whatever we do here, we equally have to do the same here to maintain the balance. So taking square root of both sides, we have x plus 5 over 4 all squared is equal to plus or minus okay, so sorry, we need to take the square root here. So is equal to plus or minus square root of 49 over 16. Then square root of this will give us x plus 5 over 4. Then it would have cancelled out the other one. Why? Because if we have square root of a squared, this gives us a squared raised to power 1 over 2. Square root in indices is 1 over 2. Then this will cancel out this, leaving us 1. In a similar manner, this will be raised to, this squared will be raised to 1 over 2, that is half. Then there will cancel out. Then what will be on top here will be 1. That's actually why we are taking square root. Then this is equal to plus or minus. Anytime we are taking square root or a root of an even number, it has to be plus or minus, because either both of them can be plus or both of them can be minus. Okay, so in this case we'll have plus or minus. Then, so when we have something like square root of a over b, then it is the same thing as square root of a over square root of b from third. Okay, so with this now we have square root of 49 over square root of 16. Then going ahead, this gives us plus or minus 7 over 4. Okay, so with this now we have x plus 5 over 4 is equal to plus or minus 7 over 4. So with this, the next thing to do is to solve for x. In this case, x will be this crossing over the sign of equality, or saying that we are subtracting 5 over 4 from both sides. We have minus 5 over 4 plus or minus 7 over 4. Therefore, we have, because of space, let's do something like this. We now have x is equal to minus 5 over 4 plus 7 over 4. That is, we are taking one of this. In that case, it will be, the LCM is 4. 4 divided by 4 is 1 times this, minus 5, then plus 4 divided by 4 is 1 times this, 7. So this is minus 5 plus 7 is the same thing as 7 minus 5, which is 2. 2 over 4. That this gives us 1 over 2 as our answer. Or x is equal to, taking the negative sign, minus 5 over 4 minus 7 over 4. And this gives us the same LCM of 4. Then 4 divided by this 4, we have 1. 1 times this, minus 5. Then 4 divided by this, 1. 1 times minus 7 is equal to minus 7 minus 5 gives us minus 12 all over 4. This gives us minus 3. Therefore, the values of x that satisfy the equation is minus 3 and half. Okay. Now let's take another example to illustrate this. Given another example, 1, 2x squared plus 3x minus 2 is equal to 0. We have to move the constant to the right hand side of the equation. We have 2x squared plus 3x is minus 2 is equal to minus 2. Then what do we do to the minus 2? We say we add 2 to both sides, plus 2 is equal to 0 plus 2. Okay, therefore with this we have 2x squared plus 3x minus 2 plus 2 we cancel out, giving us 0, is equal to 2. Then the next step is to divide through dividing both sides by the quotient of x squared, which is 2. So what do we have? 2x squared over 2 plus 3x over 2 is equal to 2 over 2. This now cancels out, then this also cancels out, giving us 1. Then we have x squared plus 3x over 2 is equal to 1. Okay, so what's the next step? The next step is to add the square of half coefficient of x to both sides. So adding the square of half coefficients of x to both sides we have x squared plus 3x over 2 plus half. What's the coefficient of x? Coefficient of x is 3 over 2. 3 over 2 all squared is equal to 1 plus half coefficient of x all squared. Okay, so for us to simplify further, we now have x squared plus 3x over 2 plus 1 times 3 is 3 over 2 times 2 is 4 squared is equal to 1 plus the same thing. 1 times 3 is 3, 2 times 4 is 4, 2 times 2 is 4 all squared. Okay, then how do we go about this? You simply take one of this plus and this sign and this other one in the bracket. So we are picking the things in bracket. So here we have x plus, looking at this side, the next thing is 3 over 4 3 over 4. Then we now extend the bracket to this is equal to 1 plus the same 3 over 4, but this time we now have to open up the bracket. 3 over 4. Okay, this time we have to open up the brackets and say 3 squared, because okay, let's throw more light on this. 3 over 4 all squared is the same thing as 3 squared over what? 4 squared. Because if we have a over b all raised to power n is a raised to power n over b raised to power n. So based on this, 3 over 4 all raised to power 2 is 3 raised to power 2 over 4 raised to power 2. So 3 raised to power 2 is 3 times 3 times 3, and this one is 4 times 4. Okay, working with that, we now have 3 times 3 is 9, divided by 4 times 4 is 16. Okay, then with this, so this is, we take the LCM to be 16, then the 1 is 1 over 1, so the denominator here is 1. So we have 16 divided by 1, which is 16. Then that's 16 times 1 will give us 16, plus 16 divided by 16 is 1. 1 times 9 is 9. Then this gives us 16 plus 9 is 25 over 16. Therefore, we have that x squared plus 3 over 4, x, then all squared is this. Then the next thing is to take square root of both sides. We now say, taking square root of both sides, we now have square root of x plus 3 over 4 all squared is equal to plus or minus, always remember this, square root of 25 over 16. Then by the time we do this, the square root will cancel out this square, that's the purpose, plus 3 over 4 is equal to plus or minus square root of 25 is 5, and square root of 16 is 4. With this now we have, therefore x is equal to, we subtract 3 over 4 from both sides. Moving over to the other side of the equation, it becomes minus 3 over 4 plus or minus 5 over 4. Okay. So if we take this on this side, we now have, this implies that x is equal to minus 3 over 4 plus 5 over 4, which is, the LCM is 4. We have 4 divided by 4, 1 times this, minus 3. 4 divided by 4, 1 times 5, we have plus 5. So minus 3 plus 5 gives us 5 minus 3, which is 2 over 4, which is equally 1 over 2. Or x is equal to, this time minus 3 over 4 minus 5 over 4, which is equal to, the LCM is 4. 4 divided by 4 is 1, times minus 3 is minus 3. Then 4 divided by 4 is 1, times minus 5 is minus 5. So this gives us minus 3 minus 5 is minus 8, all over 4. Therefore, x here is equal to minus 2, because this cancels out this to give us 2. Okay, so the roots of the equation that satisfy 2x squared plus 3x minus 2 is equal to 0 are half and minus 2. We now say therefore x is equal to 1 over 2 or minus 2, and this is the answer. Example 2. So given x squared plus 5x plus 6 is equal to 0, the first thing to do is to transfer the constant to the left hand side of the equation. So moving the constant to the right hand side, we have x squared plus 5x plus 6. What do we do to the constant to remove it from the left hand side? We subtract. Minus 6 is equal to 0 minus 6, because whatever you do to the left hand side, you equally do to the right hand side. Okay, then this gives us x squared plus 5x plus 6 minus 6 will cancel out to become 0 is equal to minus 6. Okay, then what's the next thing to do? We are supposed to make the coefficient of x squared unity, but what's the coefficient of x squared? It's already unity, because the coefficient of x here, x squared, is 1. Then if that is the case, we'll skip that step and go to the next one. What is it? The next step is to add the square of half coefficient of x to both sides. Adding the square of half coefficient of x to both sides, what do we have? X squared plus 5x plus half. What's the coefficient of x? 5, all raised to power 2 is equal to minus 6 plus half coefficient of x, all raised to power 2. Okay, so with this we have x squared plus 5x plus 5 over 2. 1 times 5 is 5, then 2 times the denominator here is 1 is 2. So we have this squared is equal to minus 6 plus, we have this 5 over 2 all squared. Okay, simplifying this further because of space constraints, we have minus 6 plus 5 squared is 25 over 2 squared is 4. Then this still goes ahead to give us the LCM is 4. Then here we have 6, the denominator is 1, so 4 divided by 1 is 4 times 6 gives us minus 24, then plus 4 divided by 4 is 1 times 25 is 25. Okay, simplifying further, we take x and take the sign here plus, and take the 5 over 2, the things in the bracket, all squared is equal to, we simplify this, minus 24 plus 25 is the same thing as 25 minus 24, which is 1 over 4. Okay, Taking square root of both sides, we have x plus 5/2 all squared. We take the square root to get rid of the square is equal to, what do we have here? 1/4. Then what will it be? Plus or minus square root of 1/4. Okay, then this clear this and gives us x plus 5/2. It has already cleared the square here, is equal to plus or minus square root of 1 over square root of 4. Square root of 1 is 1 times 1, which is 1, divided by square root of 4 is 2 times 2, which is 4. Therefore, we have this x is equal to minus 5/2, this crossing over to the other side of the equation, plus or minus 1/2. Okay, therefore we have x is equal to minus 5/2 plus 1/2, or x is equal to minus 5/2 minus 1/2. X is equal to minus 5/2 plus 1/2, or x is equal to minus 5/2 minus 1/2. When it is this, we have the LCM is 2, so in that case we have minus 5 plus 1, that is this divided by this, 1 times this minus 5, this divided by this, 1 times 1, 1. So this gives us minus 5 plus 1 is minus 4/2. This is minus 2. Then here we have the LCM here is 2. So we have 2 divided by 2, 1 times minus 5, minus 5, minus 2 divided by 2, 1 times 1, 1. So this gives us a total of over 2. So this is minus 3. Therefore, the values of x that satisfy the equation, which are called the roots of the equation, x is equal to minus 2 or minus 3. This is the answer. Okay, now we walk you through what we have done already in both exercises. They appear to be so long, but the method is easy to grasp if you understand the different steps that we've been trying to apply. Okay, so given 2x squared plus 3x minus 2 is equal to 0, the first thing to move is to move the constant to the right hand side of the equation. So we do that by eliminating minus 2. How do we eliminate that? By adding plus 2 to both sides. By the time we do that, we have 2x squared plus 3x is equal to 2. Then the next step is to make the coefficient of x squared unity. How do we do that? By dividing through by the coefficient of x squared, which is 2. So if we divide through by 2, we get x squared plus 3x over 2 is equal to 1. Then step number 3 is to add the square of half coefficient of x to both sides. Then the first thing to do is to ask ourselves, what's the coefficient of x? The coefficient is 3 over 2. So the half of it is half times that. So we take this equation and add to it the half the coefficient 3 over 2 all squared. Then whatever we do on the left hand side, we do the same on the right hand side. So we add this here, we add there. If we simplify further, what we've simply added is 1 times 3, which is 3, 2 times 4, which is 4, then to both sides. What's the essence of doing this? So that we'll be able to factorize and get a perfect square on the left hand side and have a constant on the right hand side. Okay, moving on, we've been able to do that here. So we have a perfect square here, x plus 3 over 4 all squared is equal to 25 over 4. But the question that might arise here is, how do we arrive at x plus 3 over 4? The simplest way of getting this when you are doing the solution of perfect square is to take the things in the bracket. Take this, take the sign before the coefficient of x, and take this other figure in the bracket. So in this case, we have x plus 3 over 4 all squared, then is equal to, we now continue with the solution of the right hand side, which is 1 plus 9 over 16. Then simplify and take LCM. The denominator here is 1 over 1, so 1 is the denominator here. So the LCM is 16 divided by the denominator here, which is 16 divided by 1 is 16. Then times 1 is 16 plus 16 divided by the denominator here is 1. 1 times 9 is 9. This now gives us 16 plus 9 is 25 over 16. So this is the form that we are expecting. The perfect square is equal to a constant. When we get this, the next thing to do is to take square root of both sides to get rid of the 2 that is on top here. But because of sign of equality, whatever you do on the left hand side, you do the same to the right hand side. So taking square root of both sides, we are now left with just the things in the bracket with the 2 taken care of, is equal to plus or minus square root of what we have on the right hand side. Then this is the same thing as if we have a over b, square root of a over b is the same thing as square root of a over square root of b. So if that is the case, square root of 25 is 5, square root of 16 is 4. Then this gives us that x is equal to this, moving over to the right hand side, becomes minus 3 over 4 plus or minus 5 over 4. Then this gives us that x is equal to minus 3 over 4. So with this we have minus 3 over 4 plus or minus 5 over 4, giving us two options. Either we take the first one, x is equal to this plus this, or x is equal to this minus this. So these are the two different scenarios. X is equal to minus 3 over 4 plus 5 over 4. Then we solve for x and get x is equal to 1 over 2. Or x is equal to minus 3 over 4 minus 5 over 4. This other option. Then we solve and get minus 8 over 4, which is minus 2. So the values of x that satisfy the quadratic equation is half x is equal to 1 over 2 or x is equal to 2. Okay, then going over to example number 2. The same thing. The first thing to do is to move the constant to the right hand side, and this gives us x squared plus 5x is equal to minus 6. Then the next step is to make the coefficient of x unity, but that does not apply in this case because the coefficient of x is already unity, which is 1, but we do not write 1x squared. So whenever you see x squared, then that means the coefficient is 1. Whenever you see p, the coefficient of p is 1. If you see 2p, then the coefficient of p is 2. But if you see only p, then the coefficient is 1. So in this case, seeing only x squared now tells us that the coefficient is already unity because it is already 1. So we don't need to divide through by 1 because it doesn't make any difference. Okay, then the next thing we do is we add the square of half coefficient of x to both sides. This is the coefficient of x is 5. Then half of it is 1 over 2 times 5, which is 5. Then 2 times 1 is 2. Then we take the things in the bracket. X plus 5 over 2 all squared is equal to minus 6 plus 5 over 2 all squared. Okay, then if we simplify this further, this squared is 5 squared, which is 25, plus divided by 2 squared, which is 4. Then we take the LCM. LCM is 4. Remember the denominator is 1, so 4 divided by 1 is 4, times minus 6 is 24, minus 24, then plus 25. Then minus 25 plus minus 24 plus 25 gives us 1. So we now have 1 over 4. Okay, with this done, we move to the next one, where we have that the next thing to do is to take square root of both sides to get rid of what? The square. So, but because of sign of equality, whatever we do on the left hand side, we do the same on the right hand side. Then what's the next thing to do? By the time we take square root, we have the things in the bracket here is equal to, remember when taking square root, plus or minus sign will precede it. Don't miss it because that gives you the different options for x. Then we have square root of 1 over 4, which is the same thing as square root of 1 divided by square root of 4. This gives us plus or minus. Square root of 1 is 1. Square root of 4 is 2. So with this now, we now have an option of x is equal to minus 5 over 2 plus 1 over 2, which is one option, or x is equal to minus 5 over 2 minus 1 over 2, which is this other option. Okay, simplifying this, we have x is equal to minus 2. Then simplifying this other side, we have that x is equal to minus 3, giving us that x is equal to minus 2 or minus 3. Okay, so looking at the solution of completing the square method and factorization method, it's actually obvious that factorization method is much easier and straightforward. But why do we need to use completing the square method? One, we may have to use it when the exam requires that we solve using completing the square method. Secondly, not all equations can be factorized. So the first thing to do when you have a quadratic equation is to check whether you can factorize it by doing the product sum analysis. If it works fine, then you proceed with factorization. If it does not, then it's a candidate for completing the square method. Okay, now let's go to the final batch, which is working with the standard quadratic equation. So here we are given example number 3, ax squared plus bx plus c is equal to 0. The first thing to do is to move the constant to the right hand side of the equation. Moving the constant to the right hand side, we have ax squared plus bx plus c. What do we do to that constant to move it? Minus c is equal to 0 minus c. Then this gives us ax squared plus bx plus c, we go with minus c, is equal to minus c. Then the next step is to divide through by the coefficient of x squared to make the coefficient of x squared unity. Dividing both sides by the coefficient of x squared, here the coefficient of x squared is what? A. So we have ax squared divided by a plus bx divided by a is equal to minus c divided by a. So this, we go for this, and we have x squared plus bx over a is equal to minus c over a. Okay, then the third step is to add the square of half coefficient of x to both sides. So that gives us, adding the square of half coefficient of x to both sides, what do we have? X squared plus bx over a plus half. Then what's the coefficient of x? B over a all squared is equal to minus c over a plus half coefficient of b over a all squared. Where did we get b over a? The coefficient of x. So half the coefficient of x all squared. Okay, this gives us x squared plus bx over a plus 1 times b is b over 2a all squared is equal to minus c over a plus b over 2a all squared. I hope by now you've observed that we always have the same things in that additional term that we add, because it's both of them are half coefficient of x. Continuing, we take the things in the bracket, x plus b over 2a all squared is equal to, we simplify this, minus c over a plus b squared all over 2a squared. In that case, 2 squared, which is 4, and a squared, which is a squared. Okay, then simplifying this further, we have the LCM is what? 4a squared. So we now have 4a squared divided by a is 4a. Let's do that. 4a squared divided by a. This we go for this, and we have a. We have 4a times c. We have minus 4ac, then plus 4a squared divided by 4a squared is 1 times b squared is b squared. Okay, therefore we now have that x plus b over 2a all squared is equal to, we will now work on this. This is the same thing as b squared minus 4ac, b squared minus 4ac all over 4a squared. Okay, then solving this further, we now need to do what? To eliminate this square, we need to take square root of both sides. Taking square root of both sides, we now have x plus b over 2a all raised to power 2. By the time we take its square root, is equal to, because we are taking square root here, we say plus or minus square root of b squared minus 4ac all over 2 4a squared rather. Okay, having got this, the next thing to do is to get rid of this, because square root of this gets rid of this. So this gives us that we now have x plus b over 2a is equal to plus or minus, this gives us square root of, we can separate it and say b squared minus 4ac all over square root of what? 4a squared. Then this gives us plus or minus square root of b squared minus 4ac all over square root of 4 is 2 and square root of a squared is a. Okay, this implies that we now have, from this other side, x plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over 2a. Okay, transferring it to this side, we have x plus b over 2a is equal to that. Then the next thing to do is to transfer b over 2a to the other side, giving us x is equal to, crossing over the sign of equality, we have minus b over 2a plus or minus the numerator b squared minus 4ac all over 2a. Then the LCM here is, LCM here is 2a, then 2a divided by 2a is 1. 1 times this is minus b plus or minus square root of 2a divided by 2a is 1. 1 times this gives us b squared minus 4ac. Therefore, x is equal to this. This gives us the final answer, which is what we know as the formula method. Therefore, the solution of the quadratic equation ax squared plus bx plus c is equal to 0 is the value of x is given by minus b plus or minus b squared minus 4ac over 2a. With this, you have seen that the quadratic equation, the formula for the quadratic equation was actually derived from the standard form using completing the square method. Okay, So let us go back and walk you through this to make sure that you understand it properly. Given the standard quadratic equation ax squared plus bx plus c is equal to 0, hope you can recognize this as the standard quadratic equation. So the first thing to do is to move the constant plus c to the right hand side. So how do you do that? By subtracting c from both sides. When we do that, we have ax squared plus bx, then plus c minus c is already 0, then 0 minus c is minus c. Then this is step 1. Then step 2 is to divide both sides by the coefficient of x squared. So here we have dividing both sides by the coefficient of x squared, ax squared over a, so that a will go for a, plus b over a is equal to minus c over a, leaving us with this. Then the next thing is to work towards getting a perfect square on the left hand side of the equation. How do we do that? By adding the square of half coefficient of x to both sides. Why both sides? Because whatever we do on the left hand side, we equally do on the right hand side to maintain the balance. So here we have x squared plus bx over a plus half, the coefficient here is b over a, half the coefficient of x, which is b over a, all squared, is equal to, we maintain what is here, bring it down here, and now add the same thing that we added here to this place, half coefficient of x all squared. Then if we do so, we have x squared plus bx over a plus b. How did you get b? 1 times b, b. Then 2a. How did we get 2a? 2 times a. So still all in brackets. So at this level, there is no point trying to open it up because you actually want to use it to get the perfect square. Then here we have minus c over a, which is already here, plus the new square of half coefficient of x that we've added. Okay, with this now we have this. How do you get the perfect square? Take whatever you have here, those in square, and this, and take the sign before the coefficient of x. So we take this and bring it here, we take this and bring it here, we take one of this and bring it here, all raised to power 2 to take care of this. So by the time you open up this bracket again, you'll be able to get this. You can try this out on your own. Okay, then this is equal to minus c over a plus b squared over, why b squared? Because this is b raised to power 2 over 2a, this is b over 2a all squared is equal to b squared over 2a all squared. Then 2a all squared is 2 raised to power 2, which is 4, then a raised to power 2, which is a squared. Then the next thing to do is to take the LCM. LCM of a and 4a squared is 4a squared. Then 4a squared divided by a gives us 4a. Sorry, we should be working here. Gives us 4a. Then 4a times minus c gives us minus 4ac. Then plus 4a squared divided by 4a squared will give us 1. Then 1 times b squared will be b squared, giving us, this is already a perfect square, so we retain it, is equal to, we rearrange this and make this to come to b to come first. Then we have b squared minus 4ac, because they are the same thing, all over 4a squared. Then with this square on top, we need to get rid of it before we can get the value of x. So to take care of it, we take square root of both sides, and this gives us, taking square root of this, we put plus or minus square root of the whole of this, which is the same thing as square root of the numerator divided by the square root of the denominator. So this gives us square root of plus or minus square root of b squared minus 4ac divided by 2a. Okay, by the time we flip over to the other side, what do we get? Now we have x plus b over 2a, having removed the square, is equal to this. Therefore, x is equal to this crossing over the sign of equality to the other side, minus b over 2a, plus or minus square root of b squared minus 4ac all over 2a. The LCM is 2a. Then 2a divided by 2a is 1. 1 times this minus b, plus or minus 2a divided by 2a is 1 times this b squared minus 4ac. Then this gives us the equation, the solution we call what? The formula method. This is the formula for quadratic equation. So here, where a, b, and c are constants, a, b, and c are what? Constants. Okay, very interesting. I'm sure by the time you play back the video over and over again, you'll understand what we've done. The next step is your assignment. So pause the video and note the assignments, solve them. You may wish to share your solutions with us through our WhatsApp number displayed or our Facebook page. I hope this video has been informative to you. Thank you for watching. For more information on Ivory Gate, JAMB, SSCE, private home lessons, common entrance tutorials, and computer training, call our numbers 0813-710-7935 or 0705-294-6665, or visit our website www.ivorygateonline.com or our Facebook page, Ivory Gate Education Center, Abuja, Nigeria. Thank you for watching.